Joining us today is a standout voice in the field, known for turning ideas into impact. Let's get to know and welcome the Senior Enterprise Architect at Direct System Support, Tony Owens.
Thank you very much, Ella. So yeah, I've been in the industry now. I've been doing this for over 30 years. I actually started in IT doing a lot of open systems and networking and security work. And along the way, I actually picked up quite a bit of the storage. I'm actually an IBM champion for storage. Been that for over 5 years now.
Mhm,
And done a lot within the open source community and stuff as well, which is some of what we're going to be talking a little bit about today, which is the Ceph
mhm.
object storage solution, which basically grew up and became out of a project that started in the open source community.
Awesome. Examining our first data set, which reflects insight from 42 technology business decision makers on the biggest roadblocks they face when deploying object storage. Tony, looking at the data on the screen, what stands out to you? Could you share your insight on the key roadblocks organizations face when deploying object storage and what you believe are the best ways to overcome them?
It's really interesting. Looking at this list here, the one that jumps out obviously at the top, which is the hidden cost, the egress fees, the charges. As we have moved into this hybrid world where we're mixing the on-prem sources of data with the cloud and the backup and retention of the information, we've quickly discovered that moving data into a cloud obviously is very inexpensive. They want you to put more data into the cloud and they try and find ways to get you to put the data there. But as you start to leverage or utilize that data, even within the cloud or across different aspects of it, that's when all of a sudden it seems like we watch our it's like a speedometer type of a thing on our cost and stuff. And that has become one of the biggest hurdles for a lot of companies is look, I'm interested in deploying this, but it's a little
Mhm,
bit complex, which it goes to the next point there. It's a little bit
mhm,
complex. I'm not really sure how to do it on my legacy systems. I need to get this deployed. It seems like an easier deployment option in the cloud a lot of times, but as I start to do that and I start to look at my ongoing costs that are adding up, that becomes somewhat of a hurdle for me. And so finding a way to balance the need of where I need that data to be. And that's one of the
mhm,
things that, some of the regulations and stuff that have come about, some of the things that we see, just from a security perspective, as we start to leverage this for AI and machine learning, as we're starting to leverage this data and these data pools or data lakes, if we want to call it, that are typically existing in object storage, we now all of a sudden have that concern of, wait a minute, if I start accessing that data that resides in the cloud and I start pulling that back in or pulling it into other applications, I'm going to have a very big ramp up of my costs that are associated to that. And now my value of deploying that way or leveraging it has been diminished because now the cost
mhm,
becomes as expensive or more expensive than maybe even traditional storage that I was storing on-prem. So while I don't get the advantage of that in traditional storage, the API access and the object orientation of the data and stuff, I have to balance that out with the cost. So it's an area that a lot of customers are facing, and that kind of goes into that next point there, which is difficulty managing the data lifecycle. Where do I place the data? When do I place it in which area? What are my retention and compliance policies? What if I have regulatory requirements that I have? What if I have to put a hold on something for a
mhm,
legal reason or other aspects of it? How do I balance all of those with keeping the data and where do I keep it at? And then are there regulations or requirements that require me to keep certain pieces of data in certain locations? There are now laws in certain locations that say, oh, if you've got this kind of customer data or you've got this type of information that you're storing, it must stay within the geography of or the regulatory body of a certain country or organization where it can be seen within this boundary. So we run into
Mhm.
that with GDPR, for example. European regulations require that certain data from those European or sorry, European countries must maintain and be within the borders of those countries. We see that also in some of the island areas and stuff within the Caribbean, because again, they fall either under the under Canada or European authorities and stuff. So
Mhm.
those aspects start to play an aspect. Now, the other one that's here, kind of a high point, is the performance limitations. Well, if I go to the cloud, yeah, I may be able to scale up my performance the way I want it to be, but it depends on I'm basically getting a service and I'm not
Mhm.
necessarily able to ramp up and keep my performance based on what I'm maybe needing for my application, especially as we look at things like AI and machine learning, which typically want a much higher IOPS and performance workload than we would have
Mhm.
seen with traditional object storage. I mean, we go with object storage because we like the scalability of it, the self-healing nature of it, the erasure coding, the cost savings that's there. We don't typically associate it to very high-end performance, but that's one of the
Mhm.
differences that is being made in the systems is now that we're starting to see that. And finally, we end up with some of the security concerns. How do I handle making sure that as I'm just putting this data in these large repositories and in this object storage, how do I make sure that I'm adhering to my security and access controls, making sure that I have auditability of it, that I can verify that my IT teams are ready to manage this and control it, and also
Mhm.
how do I make sure that my compliance and regulatory side of things is meeting the needs that are being required by whichever organization or body that I fall under for my compliance?
Thank you, Tony. So let's move from pain points to possibilities. This next data set reveals what IT leaders see as the biggest benefit of object storage, from cost-effective backups to hybrid cloud alignment. Tony, what is your perspective on these findings and what makes object storage so important in today's data center?
So one of the biggest things, especially as we look at the Ceph offering and as it comes into the object storage, it's not just the fact that it's object storage. It has the
Mhm.
capability of doing both file and block and the object storage. So giving that unified storage approach means that I'm going to better control my cost. We saw a tremendous number of customers over the past 5 to 10 years that have moved away from traditional tape backup. They no longer wanted to have to manage the tapes. They didn't want to have to keep up with that.
Mhm.
That was a big part of what they were doing in their backup environment, and they looked for a solution that they could move that archival data and that backup or infrequently accessed data to, and object storage became the choice for those customers. Now,
Mhm.
the complexity that came with that was number one, it was like, well, okay, it wasn't the easiest thing in the world to deploy. And as I started to deploy it, the thing that became more and more advantageous for customers was, well, wait a minute, I can use this for other things. It's not just for my archive and my backup. I now can store a large amount of videos in here. I mean, you look at companies like Netflix and some of the streaming services, they've moved away and they've got everything sitting out in object storage and they use that. You look at big enterprises like Amazon, Walmart, other companies like that, and when you go onto their websites and you look at the images in the shopping cart or the items that you're looking at, all of that is being fed out of object storage. It's all those images, those descriptions, those categories are all being stored out there, and it's very rapidly able to fill that, and of course, it grows exponentially. One of the things that I will say on that, when we talk about data and we talk about unstructured or object type of data, the analogy that I always use is very true. If I told you to take out your phone or your device that you have and look for the oldest picture or the oldest file that you have on your phone, it would predate your device. We as individuals, as just consumers, we don't delete anything. We don't want to get rid of anything. We want to keep all of our data handy. And as we've moved into the era of AI, where we've discovered that data is so critically important to modeling our environment and finding richness in what we've gathered over the generations of our interactions with our customers and their orders and what we've done with that. Having that legacy data there is very important. So having a system that can manage to start off at X point and continue to grow into petabytes of amounts of data and even larger, and be geographically dispersed. It doesn't all have to be in one location. With the erasure coding that's there, it gives me the ability to distribute this across multiple environments to make it highly resilient and available, that I never have to worry about my applications being able to get to the data. Because, I mean, let's be honest, if you went to Amazon's website or Walmart's website and tried to look
Mhm.
for something and searching for it, and if you couldn't see a picture of it or an image, you probably just move on to another site to go shopping for that item. So it's
Mhm.
very important that you have this tight integration and making sure that the system is available and can scale and grow as you need to. The other side of it is, as we moved into object storage, we actually picked up the ability to really use some metadata tagging. And this has become very critical as we look at the AI and machine learning side of things. To be able to take data that we've got out here, whether it's an image or a file or whatever it happens to be that we've dumped out as a blob into object storage, we want to be able to tag it with something. We want to be able to say, this is the pictures of your dogs, the thing that matters to me. So when I go to search and I'm starting to use a subset of data with doing machine learning or AI, I can
Mhm.
actually use that metadata tagging and other information to pull in just that segment of data that I want from the large repository of data that we have. Um, the backup piece of it, obviously that became very critical as we went into the cyber world that we are in now, where we see cyber attacks being happening regularly. And now we need not only the ability to recover that data, but we need to know that it's immutable, that it's capable of being recovered and hasn't been modified or hasn't been changed. And that was one of the big advantages that when customers went to and started using object storage for their backups, it gave them the ability to basically create immutable pools or object locks, if you will, where they could actually store that data and know that it couldn't be tampered with. It can't be modified or changed. Object storage is pretty much immutable by nature. You don't edit an object once you've created it. It's just put out there and left out there. You may publish another object, an update to it, but it's versioning. It's kept in different versions. Now, it's in my opinion, it's still not as completely secure as a tape is, because I can take a tape completely offline and completely inaccessible other than putting the tape back in to restore it. But object storage with its lock capability does give me that advantage. It is a logically air gapped copy that is
Mhm.
basically immutable in its very nature. So as customers look at simplifying management, I want to reduce the number of devices and complexity of my environment. And I want to make
Mhm.
sure that everything's readily available and quickly in case I need to do, whether it's I'm going to pull a new set of data to do AI with, or I need to do something I need to do a restore because I've got a system or a group of systems or a set of data that was attacked by a hacker and encrypted. I need to be able to get that up quickly and effectively and have it readily available for me.
Thank you, Tony. Now that we've seen what makes object storage essential in today's data center, let's take a closer look at how IBM Storage Ceph is putting those benefits into actions. This slides highlight several real-world use cases. So, Tony, can you walk us through how these capabilities translate into performance gains and operational efficiency for modern workloads?
Absolutely, Ella. So, yeah, as I mentioned earlier, one of the big advantages of the IBM Storage Ceph solution is that it is a unified approach. It is a unified storage cluster. It can provide for that file workload that you need. So, the user's Excel files and PDF documents and PowerPoint presentations that we all see too many of, but also the object storage, whether it's coming from a backup, whether it's video files, whether it's other information, those can all coexist on the same storage. They have different ways of accessing it. So you're not going to be accessing your object blob on the block side or vice versa, but it's all stored in the same centralized system, and it gives you different ways of connecting to it. The
Mhm.
other side, as I mentioned kind of a little bit already, as we start to look at, IBM's very big into the Watson X AI piece, and that's been a very big focus for IBM and for a lot of companies out there. There's Red Hat, OpenShift, AI. Many other systems are starting to move into the AI and machine learning, and customers are starting to leverage it and utilize it. But the one thing that they found is that number one, I need massive amounts of data to train a model or even fine tune a model. And I need that data to be fast. I need the access to be very quick because when you start talking about training initially or fine tuning with AI, you're talking about very expensive servers that are doing this. They're sitting there with GPUs that cost a tremendous amount of money. And the one thing you don't want is that GPU enabled system to be sitting there idle. It is probably the most expensive system that you will either leverage and utilize in a cloud or on-prem. So I
Mhm.
want the storage to be able to keep up with that. So IBM actually offers storage ceph options that actually use NVMe drives inside it to actually provide that very fast, high, robust performance that you would need to be able to
Oh.
feed a data lake or house a data lake that was going to feed an AI environment. And these can be, obviously it can be built on your own bare metal systems, or there's an option from IBM that you can actually buy the systems to make it easily deployed. It comes as a basically a minimum 4 node cluster, and it allows you basically to get your IBM storage Ceph environment up and running relatively easy. And actually,
Mhm.
IBM even offers it as a service if customers want it not only in the cloud but on-prem, where they will actually manage the underlying infrastructure of it and let the customer basically just be a consumer of the storage, even though it's on-prem. And that again goes back to some of that regulatory compliance that we were talking about, that maybe you've got a requirement that says your data must be kept on-prem, must be kept within your facility, or maybe your data is so sensitive that you wouldn't want it to be out in one of the cloud providers. So this gives you the option to take advantage of that, but still leveraging the normal API capabilities and S3 protocols that your applications are already familiar with, that maybe they were designed for, fully supported within a solution that runs on-prem.
Great. Thank you, Tony, for that insight. Now, let's turn over our attention to a critical aspect of enterprise storage compliance. This next slide highlights how IBM Storage Ceph addresses stringent regulatory requirements. Tony, from your perspective, how significant is this level of compliance in today's data-driven environments, and how does it shape the way of organizations evaluate object storage solutions?
So the couple that's highlighted here are really around the financial industry. So it's the Securities and Exchange Commission's requirements, as well as
Mm,
the Financial Industry Regulatory Authority. And these were specific regulatory requirements that a company assessed and said, basically, from an IBM storage Ceph perspective, that it met and or exceeded these capabilities that were required by these agencies. Okay, that's one thing, but why is that important? Why does it really matter when you talk it? Well, if any of the folks are on the phone are dealing in the financial aspects of it, of the industry, and they've got financial data or they're using financial data in a data lakehouse, these are some of the very requirements that they're going to have to validate and prove in their own filings and other information about their environment, that they've got this level of compliance in their systems, that they've got this level of encryption and control of the data. And IBM Storage Ceph Object Lock is another aspect of that. So if you have a legal requirement to hold data, maybe it's from a healthcare perspective, maybe it's from a lawsuit that's coming in that you need to hold data for a specific amount of time and you need to make sure that that data can't be deleted or
Mhm.
changed or modified. That is what an object lock can actually do. And it meets the requirements that these organizations have set out that said, we need to know that you're keeping this data in this fashion and you have to prove that it is, it's for the legal requirements of it. So as we look at data, many companies, especially as we look across financial, healthcare, other places, there are requirements to keep records for a period of time. And you don't want to be going back every time and saying, okay, now I have to go find all the tapes for this, or don't want to have to go find all the systems of record where this data was at. If we're storing
Mhm.
this data in an object storage, we know that it's been out there. We've actually put the date that the lock requirement ends, and we know that at that point the data can automatically be deleted on the system unless there's been a change or an additional hold request or whatever. So once we set these in the system, we don't have to worry about the fact that, oh, somebody could accidentally overwrite it or somebody could hack our system and change that data because it is very much immutable by nature and designed
Mhm.
to work within these different regulatory requirements and rules to meet these stringent requirements that we see. And this
Mhm.
obviously is just actually a small subset of what we see coming. As we've looked across the industry and we've seen things happening with DORA and GDPR, we have individual states now starting to create their own requirements and stuff for keeping data and keeping information. And again, that goes back into not only from just the data reporting perspective and if I've got a lawsuit or I've got something that says I have to keep that data, but as we look at now, just protecting our systems in general. So I point this out because as we looked at the aspect of, well, what happens if I get hit by a cyber attack? What happens if something happens in my data center and my backup server gets, toasted or gets, something happens to the metadata and stuff in there? If I've got backups of that data and I've put it out in object storage that again is immutable by its very nature, I know that I have a copy of that data that I can get to, that I can go back to. From a legal perspective, I've got the ability to validate and run a report and show that I've set the appropriate locks and things in place to allow for that to happen. So
Mhm.
again, I can walk with my head held high in the courtroom and say, yes, I've met these requirements, or speak to my insurance company and say, yes, I've done everything that you require
Mhm.
from your perspective for cyber compliance or other things. And again, when it comes to, dealing with that press release, I mean, I don't know anybody that looks forward to the day that their company is the one that's hit by a cyber attack and has to go out and talk to the press and say, yes, we got hit, we got breached, our systems were affected by a cyber attack, or the data was encrypted in our system. But if I was that person, I would much rather be going out and saying, yes, we did have an incident where, through an old system or whatever, we had a breach or we had something where, someone was able to get in and encrypt some of our data. But
Mhm.
because of the fact that we use a very sophisticated and secure object storage in our environment, we were able to rapidly recover that information and get back online. And obviously you hope that the controls and stuff were in place that didn't allow them to steal anything off the systems. Maybe they were just able to encrypt the existing data, but now we were able to restore that. So I use this list of some of the compliance and worm capabilities. And if anybody doesn't know what worm is, I know that's it's certified worm compliance. That means write once and read many times. And that's what object storage is really designed to do. You put an object out there and it's out there forever. It's immutable by its very nature until it expires or until you've told it to remove from the system. It's very much, it exists as it was when you created it, but it's designed to allow you to read it multiple times over. And again, that's a good example, as I mentioned earlier. Think of the perspective of Netflix. You're streaming a video, right? You want to go watch the latest, episode of whatever show you're watching. You and about a million other people want to do that. So it's designed to be written out there once and for multiple people to be able to stream it. Same thing when we look at AI, if we're looking at, taking our data and learning more from it, and we want to dive into more of our customer information, that gives us that ability. But that worm compliance means that I can guarantee that it's going to be written once and it can never be changed. It can be read many times, but it can never be changed.
Perfect. Thank you so much, Tony, for that. Now that we've covered, the core use cases and technical strengths of IBM Storage Ceph, let's take a moment to reflect on what this all means in practice. Tony, based on your experience, how do these capabilities come together to support real-world performance demands? And what should teams be thinking about as they plan their next steps?
Sure. So, let's take it from the perspective of thinking of it from a normal perspective of somebody looking at, okay, I've got these particular workloads in my environment that I'm going to need to continue to grow and deal with storing that information. Now, I can make the choice of, do I want to have it on-prem, or do I want to have it in the cloud, or do I want to have a hybrid of the two? Maybe I want some of the data kept on-prem and some of the data put off-site, or maybe I want it to be across multiple sites for flexibility. And also, as I look at this now, do I really want to have silos of storage? Do I want to keep my traditional transactional data in block storage and have my user files in a separate storage system, and then have my backups and archive and data lakes and data warehouses in a separate storage system? Or would I want the capability of putting all that together? And how do I want to access that data? Do I want to have a system that's mounted with that volume directly accessing it and going through that system? Or would I rather be able to call it from an API call, from a web page, from any other application that I'm using, be able to reference and utilize that particular piece of data? Of course, it has to be highly reliable. I can't have any data loss. It has to have self-healing capabilities. If I lose an entire server, if I lose a disk, if I lose an entire location, I need it to autonomously and automatically recover and be able to handle multiple failure domains so that if something goes down on-prem, well, I can leverage the parts that are out in my hybrid cloud. So I'm leveraging the pieces that are in the cloud or in another data center so that I can still access that information and use it. But I need it to be very cost effective. I can't have rampant cost. And as we talked about with, having these different silos and platforms of systems and stuff, the cost of that obviously ramps up quite dramatically as we look at that. And I need it to be very secure. We have seen the number of cyber attacks increasing dramatically in the industry. And I hate to say it, but it directly relates to, if you follow cryptocurrencies and stuff and you look at the rise of the price of cryptocurrencies, you will see the number of cyber attacks elevate dramatically every time the cryptocurrencies rise. So making sure that our data is secure, that we have data that is protected, that can't be read, stolen, utilized, making sure that we're protecting our customers' information, especially as we build out these larger data lakes of information that we need for AI and machine learning. So all of those things together start to paint a picture. I need a system that can grow and scale dramatically. I know my data is going to continue to grow. As we talked about earlier, I can pull up my phone right now and I have images and videos and pictures of my children from back in 2001 and 2002. And I can tell you my phone is not that old, but I still have those pictures on my devices and it transfers from device to device. So obviously, we're going to continue to increase and store more and more data out there. We need more and more of that data to provide our environments hungry applications like AI and machine learning. We have to have that reliability. As we've looked at more companies now, we used to think about, there used to be a term that we would use and we would call it the nines of availability, right? Four nines of availability, five nines of availability, six nines of availability. Well, quite honestly, today's world, we've moved into everything must be available 24/7 with zero downtime. We have to have the ability to access that data. Our livelihoods depend on it. And we've gotten very much into that aspect. We also need that zero trust capabilities, right? From a security perspective, we need to make sure that we can control who has access to data, what they're doing with that data, what we are doing with the regulatory and compliance standpoint, because it's not just I need to be a good steward of your data. Depending on where you are in the world, you could
Mhm,
actually be very much in trouble financially and
mhm,
legally if you allow your data to be breached or taken or utilized. So that's something that's now companies are facing worldwide is I
mhm,
don't want to be the guy that's going to jail because somebody breached my system. But I've
mhm.
got to keep my investors happy. I've got to keep the people that are buying our stuff and making our solutions affordable to people by controlling my cost and not letting it get out of control. The
Right.
IBM Storage Ceph addresses all of those concerns, providing that scalability, reliability, the cost effectiveness of it, the data
Mhm,
security, and that ability to have a really unified storage approach that allows for not only all the traditional access methods, whether it
mhm.
be NFS or block storage via iSCSI, but also API calls and S3 compatible object storage.
Right. So, Tony, we have a question from the audience. What is the major difference between the IBM Storage Ceph and the Community Edition of Ceph?
That is a really great question. So, again, Ceph was very much grown in the open source community. There is a community Ceph edition of Storage Ceph. And what that gives you the ability to install and utilize Ceph on-prem or in the cloud free of charge. But what it boils down to is the supportability of it. So if you run into a problem, you're actually dependent upon the community to respond to help you to address it. And that may mean opening yourself up to a little bit more insecurity, I guess is a good way to put it, because you're actually using very much community providers, people who are writing code, people who are doing the development in the back end. And if they're fixing something and patching something and making a change for you to address something, how secure is that? How much do you know about this person that you're communicating with via email and stuff? So when it comes to the IBM version, obviously IBM is supporting it 100%. And all the so they pick a release of the code, they certify it, and they provide support around it and stuff. So you're not dependent upon community folks in the industry to help support your application, but you have IBM's level of support that is a entire team dedicated to making sure that the software works, that if there's a problem that they can address it and fix it. And obviously the other side of it is you can actually bundle that obviously with hardware from IBM to not only have the support for the software, but also for the hardware as well. So you have the old analogy of one throat to choke, so to speak.
Got it. Thank you so much, Tony, for answering that question.